About histograms. A histogram, like a bar chart, is made up of columns plotted on a graph. However, each column represents a group defined as continuous quantitative variable. The big word here is quantitative. We do specify continuous, but it doesn't mean that you have to use continuous data within it. We just set it up as continuous, and we're saying what goes in these individual bins. So the continuous is setting up bins, and we just put things in that bin. So your big thing is quantitative. Quantitative means we're measuring something. So quantitative histogram, categorical is a bar chart, whose height indicates the size of the group or how many frequency you have. Usually there is no space between adjacent bars. So we look here. Bar graph, spaces, categories. Histogram, no spaces, and we're going to use numerical data. We're going to have a range of values. I'm going to get my sheet out. Got it. By George, I think I got it. All right, but your big thing is categorical, bar graph, numerical, histogram, or quantitative. What was this called? What was it called if it was categorical, but I want to use one of these Q words? Yeah. Qualitative, yeah. Like I said, I always just remember quantitative, and I'm like, the other one is. All right, so today we're going to talk about histograms. Histograms have some quirks to it. So this histogram shows the time that students spend doing homework every night. So we look at here, and we have interval 0 to 15, 15 to 30, 45, 60, 65, and then 90. These are all our different intervals. Note that this is continuous. We have numbers that represent 0 all the way through 90. Now, we have a big question here. Let's say you spent 45 minutes doing homework. Consider these bins. Well, a lot of times we call these bins. In fact, I'm going to put that on there. These are called bins. In this case, I have kind of 1, 2, 3, 4, 5, 6 bins to put numbers in. Now, I study for 45 minutes. 45 minutes is right here. It's right in the middle of 2 bins. I can't put that 45. I can't count that person as studying between here and 45 to 60. It can't fall into both bins. Then what bin does it fall into? Yeah. It will always fall into the bigger bin. So if you study for 45 minutes, you will fall into the 45 to 60 minute bin. That's very important to understand, and this works for all histograms. If you are between bins, you go to the larger bin. So if you're 45 actually goes into this bin. 60 goes into that bin. 75 goes into that bin. So if someone studied 90 minutes, is their data represented on this histogram? No. So no one studied 90 minutes or more. 90 minutes would have to fall into that next bin, and we don't have that next bin. So here's an important thing for the intervals. We do say something like interval of 45 to 60. We do say that. But it's not really. So an incorrect way, we do this. We write it like 45 to 60. That's how we typically write it. But that's not what we're meaning. What we actually mean is 45 to any number less than 60. That's an easy way to write it. That it's not 45 to 60, it's 45 to any number less than 60. Because as soon as it's 60, it goes to the next bin. So if we're writing what's called a frequency table, we would use these things. So what would be wrong with saying a bin size 0 to 14, 15 to 29. Because wouldn't it make sense to just write this as 45 to 59? Wouldn't that just make our life easier? What would be wrong with that? Brooke?
It's like 59.5, it's still going to go with that.
It doesn't know what bin to go into. If I say, so if I had 0 to 14 and I study for 14.5, I don't have a bin to go into. That's why we do not come up with shorter bin numbers. So we have 14.5. That wouldn't have a bin to go in. That's why I started out by saying this must be continuous. Continuous would not be 0 to 14, 15 to 29, 30 to something, because we'd have those gaps. That's not continuous. So be very clear that you should never have two numbers written here. Here's going to be the biggest mistake that I see on tests, on projects, is you're going to actually, let me erase that real quick and write a big thing. I'm going to see people that go, okay, that's 0 to 14, and then you'll put 15 right next to it. It's always one number that goes there. But we do know that that number goes into the next bin. So we always just write a single number under each of these. Is that clear? All right, so a lot of times to help ourselves do that, when we create our bins, we write it like this. So my first bin is 0 to 15, but I write it as 0 to less than 15. You do not need to write it this way. I am not grading that you write it this way. If you just wrote 0 to 15 and you know that 15 goes into the next bin, awesome. You can do that. This is just an easy way to remember that 15 goes into the next bin, which means my next one would be 15 to less than 30. Then we'd have 30 goes to less than 45. Then we have 45 goes to less than 60. Then we have 60 goes to less than 75. Then we go 75 goes to less than 90. Once again, no one studied for 90 minutes because then we'd have to have another bin. Now, this is called a frequency table, where we just write how many people studied between 0 and 15. Well, we're going to get that information from right here. These numbers along the left-hand side are our frequency. So how many people studied between 0 and 15 minutes or did homework? One person. How many people did 15 to 30? Two people. How many people did 30 to 45? Five. The next one is 10. And then 4. And finally 7. All right, questions on a frequency table. How it relates to our histogram. Once again, we pulled this lesson out. We used to teach this yesterday along with the bar graph. We pulled it out for this one big fact. We noticed on tests and projects, too many people were writing double numbers here. That's not how it works. That you just write your single thing. So I'm going to write 0, 15, 30, 45, 60. We have single values between each bin, knowing that that number goes to that next bin. I'm stressing that because on the test and on projects, I'm going to take extra points off if you do that, if you write two numbers there. All right, let's continue on with our histograms. All right, the boys and girls basketball team wanted to raise money to help to buy new uniforms. They decided to sell baseball hats with the school logo on the front to family and friends. To obtain the correct cap size, students have to measure the circumference of the adults who want to order hats. The following data set represents head circumference in millimeters of the adults. Well, you get an extra small size if your head size is between here and here. Small if you're between 530 and 549. Now, what might be wrong with these scales? Camden.
It doesn't say for in between, like if you're 529.5.
What if I'm 529.5? So maybe a more correct way to have written this is not that 529, but less than or equal to, just straight up less than 530. Why might they get away with doing it how they did it? Nathan?
There's no point fives.
There are no 0.5. So the way they set it up is okay, but when you draw your histogram, you can't draw those two numbers, and we'll talk about the histogram later on. So right now, I should be looking at this and going, let me go back real quick. When I draw this histogram, I cannot write 529 and 530 in the same place. So I'm just going to write the 530. So my histogram should only have 510, 530, 550, 570, 590, and 610. Which is good for you because you're always just going to take this left number are going to be the ones on the histogram. If you mess up the right side, you can use these to get your histogram values. We'll see those in a second. All right. In order to do a histogram, we have to know how many people our frequency have this size. So an easy way to do this, especially when you have a ton of numbers, is called the tally method. That I'm actually going to go left to right. I'm just going to make a tally mark for whatever bin it goes into. So if I'm 513, I'm going to fall into this bin, and I'm going to cross out the 513. At 525, I'm going to put a tally mark in that same bin, cross that out. 531 goes into the next bin. 533 goes into the next bin. Kind of nice because a lot of these look like they're in order. So if you could, go ahead and tally them all up and then give me those frequencies. We would have 2, 8, 15, 9, 4, 2 with a total of 40 different people. If you count it, it should add up to 40. All right. Then we have two histograms. This is our original one. I'm going to point out a couple things. First thing, what's that?
It's like a break that it just skips from 0 to 510. So write it down for that was
It skips from 0 to 510. So they say they're missing a bunch of numbers. This is what you're going to do. Because remember, so if I look at 510 to 530, what's the distance from 510 to 530? 20. That means every one of these has to have 20 between them. So as soon as I count 20, 510 to 530 is 20. You add 20, you add 20, you add 20, you add 20, you add 20. You cannot change your scale once you picked your scale. So to accommodate for that and not have to go into 0, we're just going to put a little jaggedy thing here saying I'm going to skip all the numbers until the important 510. Okay, is that clear? So if you're going to skip stuff, put that little jaggedy thing and we can skip numbers. You cannot say this first bin is from 0 to 530. That's not what we're going to do. We're going to skip until we get to the 510. All right, how many people did we say was between 550 and 570? We said 15. So we should probably add that to this bar chart. It's not finished. Histogram, I should say. How many people were between 570 and 590? 9. All right, how many people were between 590 and 610? How many? 4. And our final category had 2. All right, we fill those in. Don't spend a bunch of time coloring these in. Just tick, 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 tick. Not a big deal that we color them in. Well, this says this is the histogram of head circumference. This says this is the histogram of head circumference. Why are there two different histograms? Or why are they different? If they're doing the same data, why are they different? Anna? Oh, we changed the bin size. This one has a bin size of 20. I'm taking everyone from 510 to 530. I have a bin size of 20. This one has a bin size. I will also note that sometimes these are called class sizes as well. Bin size is the same thing as class size. This class size is smaller. So if we change the class or bin size, it's going to change the way the graph looks. Which histogram is probably more useful? Take a second and look at the data. Which one is more useful? Ross? Why the second one?
Because it's more specific.
It's more what?
Specific.
It's more specific? Okay. Who thinks the first one would be more accurate, though? Yeah.
The first one because those measurements are what they use for the sizes.
Yeah. So I agree that this one's more specific, and a lot of times more specific is better. So maybe 75% of the time more specific, that's the better graph. So most of the time I would choose this one. But if you look at what the data is representing, I need to know who's getting an extra small, a medium, a large, an extra large, and an extra large. That's what this, whoop, going the wrong direction. That's what this one's showing. Yes, we can see more specific data of what head size is really big, but it really doesn't tell me what size hats to buy anymore because I'd have to count every 2 of these and add them together. So I agree that most of the time the more specific one is better, but in this rare case, this one's actually more beneficial. Does that make sense why you'd use this one versus the other one? What interval would a head circumference fall in if you were 570 millimeters? So your head is 570 millimeters. Which bin would that fall in? Brooke? 570 to 590. Where else would it fall? You know what I'm asking? 570 to 580 if I'm looking at the other one. We could just leave the 570 to 590 if you're just like, I get it. But it also falls into 570 to 580 in the other one. Once again, when I say 570 to 580, I am implying that 580 goes to the next bin. You have to understand that when we're talking about histograms, that goes to the next bin. How many head circumferences are there that measure 570 to 590? You know, that was a hard question. Yeah. 9, yeah. Don't overthink it. We wrote it down the other side. We have a chart that has it right here. There are 9 of them. All right, so that's the nuts and bolts of a histogram. Now what we're going to do is we're going to make our own histogram. And in fact, you're going to make this histogram. I actually did all the tallies. I have all the frequency for you. Your job is to create a bar, not a bar graph, but a histogram. Make sure you have a title on top. Make sure you have a title down here. Make sure you have something here. Make sure you have continuous numbers on the bottom. You may have to skip some numbers because I don't see anything between 0 and 80, so use that little janky thing. And take a second, finish that up, and then when you think you have it, I'll check it over. Just a reminder, make sure you're putting titles on things. I got a major title, movie length. I have minutes on bottom. Frequency is really a good one to put on your side. You can put number of things, but frequency always covers how many you're counting of. So frequency is just our traditional, just write that up.